This is your timetable. Chemistry, maths, physics, last period maths. Last period is maths, right? Timetable changed.
Yeah, this is standard.
No, this is standard. If you have any problem, no maths you can leave. Mostly parent-teacher meeting is only there. I mean, we'll take till 6:10, 6:30 like that. Thereafter, you can leave. Okay. Today I will post this. Today our next topic is magnetism and matter. Very important and easy also. Magnetism and matter. Actually, I could teach, but on the board, but phone charging was over. That's what I'm taking on the screen. Okay. Magnetism and matter. No objection, na? 1.5 hour charging over 85% is over. Only 10-15% is there. No. That is a new phone also. When you are using Zoom, na, extreme power consumption will be drained. With video on. Na? No participant there also. If you use the Zoom, na, it will drain like anything. Who told? No online, but some students are requesting. We committed during the admission, not we, that marketing people committed. Okay, leave it. That is different topic. So today onwards, student, magnetism and matter, very easy. Here in this chapter, we'll talk about real magnet. You know, our Earth also very huge bar magnet. Huge bar magnet. So most of the bar magnet, I think you might have seen a bar magnet in your laboratory. Actually, what is the shape of the bar magnet? Respond, it is a cuboid shape. It is a cuboid shape like this. It is exactly cuboidal shape. But for easy understanding, simple understanding, I will represent like this. So it has how many poles? One is North Pole and other one is what? South Pole. Be careful. Magnetic pole. Pole means the entire polarity concentrated a very, very small region. That's what we are calling pole. Don't feel there is a misunderstanding that pole means this entire side is a pole. There is a general misunderstanding. Is there? It is actually wrong. Pole means what? Entire magnetism confined only at the two small regions. That is the meaning of the pole. Pole means very dot. And one more important thing, this North Pole, South Pole do not reside on the surface. Slightly they go inside. Why? Unlike this North Pole, the South Pole do not reside on the surface. Slightly they go inside. Slightly they penetrate inside. Why? Unlike poles, slightly attracted each other. Na? North and South Pole, unlike poles, so they attract each other slightly, they penetrate inside. So the shortest distance between the two poles is called magnetic length, ML. ML means what here? Magnetic length. Hereafter, in the future, if I say length of the magnet, you should understand that is magnetic length. You should understand that is the shortest distance between the two poles. Understood? And also one more length also there, that is called geometric length. The shortest distance between the two sides is called GL. GL means what here? Geometric length. Two lengths are there. But in major applications, we use not major. In all application, length of the magnet means magnetic length only you have to take. And experimentally, it is proven that magnetic length equal to 5/6 times of the geometric length. Very, very important relation. You should remember at your fingertips. And you know very well, magnetic field line. Magnetic field line means if you keep any test North Pole, in which trajectory it is going, it is repelled by the North Pole and attracted by the South Pole, no? So the path traveled by the North Pole is only called what here? Magnetic field line. Understood? So the magnetic field line always acting from North Pole to South Pole. And one very, very important note, the magnetic field lines are open loop, closed loops, sorry. Closed loops. I mean, inside also they will travel. But if you take electric dipole, this North Pole is similar to positive charge, South Pole is similar to negative charge. In fact, North Pole also can be called as magnetic positive charge. Magnetic positive charge also you can call. This bar magnet also can be called as magnetic dipole, like electric dipole. In electrostatics, you studied no electric dipole concept. Same way here, every bar magnet is acting like a magnetic dipole. And one more important thing, if you take any bar magnet, there should be one reference point to measure all the distances. So that's what the midpoint of the bar magnet is called what here? Origin or frame of reference. All distances, all angles, we are measuring from the origin only. And the distance between the North Pole must and should be L meter, and distance between origin and south pole also L meter. So L plus L, 2L is called here magnetic length. Two L, 2 into L.
That is magnetic length.
Huh?
Let's asking 2L is equal to M1.
ML. Yes. Magnetic length means what? 2L. You should forget geometric length. For your idea only, I explained. But in all application, we don't consider geometric length. Understood? For your idea, for your information only, I gave the relation. Sometimes question setting will be done with this equation also. That's what, for your information only, I mentioned that. Length means magnetic length only. 2L is nothing but magnetic length. Now, some important, before entering into the real chapter, some basic terminology I must introduce to you. First of all, pole strength. What is that? Pole strength. That is denoted with the small m. It is similar to electric charge in electrostatics. Or you can also call it as magnetic charge also. You can define pole strength as strength of a pole. How can you define? Strength of a pole. Strength of a pole is defined as pole strength. So north pole pole strength is denoted with plus m, and south pole strength is denoted with what? Small m. And one more important term, dipole moment. Dipole moment, that is denoted with the symbol capital M, or magnetic moment also I can represent. Magnetic moment. Magnetic moment also I can represent. Moment means what, students? No, wrong. Moment means rotation. In most of the instruments like galvanometer, ammeter, electric motor, generator, toy cars, they use motor, engine, etc. The magnet will rotate. If any magnet placed in the between another two magnet, it will rotate. Electric motor. How electric motor will function?
Using
Current what you are sending,
it will create a magnet.
when it is passing through the one current carrying coil, this is one north pole, this is one south pole. Here one coil is there. If you switch on, current will pass through this coil. This current carrying coil acting like a magnetic dipole. So it will rotate continuously, it will rotate. So to understand the rotation, we need one vector quantity. That's what purposefully we created this vector quantity. Correct or not? Without vector quantity, we will not discuss anything. Na? Understanding? To understand the rotational properties, how much angle it rotated, what is the angular speed, how much torque acting on that, some operations, vector operations to understand, we need one vector quantity. Na? So purposefully we created one vector quantity. That is called magnetic moment. Understood? Derivation is not there because we only created wantedly. So that defined as if you take any magnet dipole, as I told, how many poles are there? North pole and south pole. Magnetic field line inside the magnet always from south pole to north pole only, na? Correct or not? That is called direction of the magnetic moment. In fact, here length of the magnet also vector quantity. Length also acting from south pole to north pole. Very, very important note. Length also vector here. Length also vector. What a direction of the length here? South pole to north pole inside the magnet. inside the magnet. So I can write magnetic moment equal to product of pole strength and into length vector. That's it. This is the expression for what here? Magnetic moment. Most powerful equation you have to remember. It is similar to dipole moment in electrostatic. Dipole moment equal to how much? Electric charge into length of the dipole. I hope you people have remembered this. In the first chapter, I only explained to you. Product of charge. Here, electric charge is analogous to magnetic charge. Length is similar to magnetic length. That's it. Now, definitely you will ask me, sir, how this magnetism, real magnetism was found. I think in your earlier classes, like 10th standard, 7th standard, 8th and 9th, I don't know your status because pandemic also there. Okay, in the schools also they were discussed or deleted. I don't know the exact status, but 5 minutes I will brief. The real magnetism was discovered by a shepherd when he is looking after that goats and sheeps. He stepped on a special rock, special stone with his metal boot. Then he is unable to withdraw that iron shoe back. Means he noticed that stone, that rock has some magical power. It was attracting iron bolt, metals, etc. Later they named as a lodestone. What the name of the first stone? Lodestone. Lodestone. Later it was named as a magnetite in Greek language. All discoveries were happened in Greek country only. Most of the famous scientist was born in Greek only. This magnetism also was discovered, observed initially in the Greek country only. It was named as a magnetite. So after transferred into English language, it is called as magnetism, magnet or ferrite, like that. It is made of iron only. If you immerse iron for some millions and trillions of years, Earth is a huge magnet, na? One magnet only can convert other metal into magnet. Correct or not? Actually, why real magnetism came, tell me, because of moving charge only, na? Correct or not? Inside the iron also, if you see this surface, atom containing midpoint nucleus is there and electrons are revolving in the anti-clockwise only, na? Correct or not? Means, shall I write? Every orbit is acting like a magnetic dipole. Every orbit is acting like a current carrying coil, na? Current carrying coil is acting like a magnetic dipole, no? Please say yes or no? But why all atoms will not show the magnetism? See why? Because one orbit is revolving anti-clockwise means another orbit revolving the electron clockwise. This magnetic moment, that magnetic moment nullified. Sometimes net magnetic moment will be 0. So that atom will not perform any magnetism. Are you understanding? But in some atoms, what will happen? With the magnetization, all electrons are revolving in the uniform direction. So there you cannot. Yes. You are magnetizing, na? You play with the magnets, no? You have taken one bar magnet, you rub it to the steel rod for some time. What you did actually, you oriented all orbits in uniform direction. What you have done actually, you aligned all motion of electrons in one uniform orientation.
So for me, on down so only attraction.
Yes. Then only that is acting like a
orientation of direction, small time only. Then it will go and.
Very good. He is correct only. For very little time interval only, they will be aligned in this direction. After heating, tapping, again it will go back to its original state. If you want to transfer to permanent magnet, For long time, you have to keep in the magnetism. Powerful magnetism is required. Correct or not? Okay. For example, that is the reason. Means if you see this magnetic North Pole, why it is formed into North Pole? Because all positive charges are revolving in the anti-clockwise like this one, you know. N letter means it is similar to current revolving in the anti-clockwise direction, you know. You got my point? Understood my point, na?
Yes, sir.
Yes or no? Means on the side where the North Pole has been formed, all positive charges are revolving in the anti-clockwise. But in reality, electrons are revolving in the clockwise only, na? Actually, positive charge will never revolve. That is a conventional only we are speaking. Means positive charge is revolving anti-clockwise means electron is revolving in clockwise only, na?
Yes, sir.
Correct or not?
Yes, sir.
Why the South Pole is formed here? Why the South Pole is formed? Because the positive charged current, positive charges revolving in the clockwise direction only. So every atomic dipole will constitute clockwise magnetic moment. That's what that side is acting like a South Pole. Here also real magnetism also because of the moving charges. Understood? Now, shall I say this magnetic moment equal to current into area of the cross section? Total current contributed by the electrons and area of the surface. Do you have any objection?
Yes, sir.
Any objection for you? I will tell every orbit is acting like a circular current carrying coil. I will tell. I am telling you, do you have any objection? No objection. No? So I can write, I can define magnetic moment also current in the orbitals into area of the side. Understood? Shall I equate?
Magnetism or magnetic?
Magnetic moment. This is also magnetic moment. Magnetic moment.
Small and
Pole strength. Small m is called pole strength or a magnetic charge. North polar, south polar. Capital M is what here? Magnetic moment. With your permission, shall I equate this both?
Yes, sir.
Both are same only, na?
Yes, sir.
So I can equate very confidently. M into 12 equal to how much? Current into area of the cross section. Yes or no?
Yes, sir.
So pole strength can be written as current into area by length. What are the MKS units to measure the pole strength? Current is what here? Ampere. Into area is what here? Meter square. Length is what here? Meter. Meter cancels out. So how much? Ampere into meter. These are the MKS units to measure the pole strength. What about the units of magnetic moment? Units of magnetic moment. Current into area, na? Current means what? Ampere
Meter square.
into meter square. Units also will be asked sometime in your JEE mains. Paper standard is very low. He will test your knowledge on units also. Means if you take any north pole, north side of a magnet, if you take any north side of a magnet, how the current is moving? Anti-clockwise only, na? Yes or no? Real electron. Electron will never discuss. Convention, no. Convention means tradition. Our first person who researched on the current, till now we are following in all circuit diagram, direction of current means direction of positive charge only we know that is lie, but you should not question. You have to follow that convention. Anti-clockwise. Current is anti-clockwise. So that side current is anti-clockwise means curl your fingers. Take your right hand, everyone. Thumb is coming out, na? Correct or not? So means magnetic moment also coming out of the screen. So magnetic moment is coming out of the screen. Imagine one arrow is coming out of the screen. What the tip of the arrow looks like? Magnetic moment only, na? Correct or not? What the tip of the arrow looks like? Aerial vector only, na? Please say yes or no. Aerial vector, length vector direction same only. Vishwanath. Understood. Your length vector also having the same direction I am telling. North side you are looking means length vector is coming out of your paper. Aerial vector also coming out of your paper. Magnetic moment also coming out of your paper. If you have any small doubt also, use your right hand thumb. North pole means on that side all currents are orbital currents are anti-clockwise only, na? Say yes or no. Now south pole means what? South pole means what? Current is revolving in the clockwise only. Say yes or no. Current is in the clockwise. Same right hand thumb rule. Everywhere hereafter right hand thumb rule only. Curl your fingers in the clockwise. Thumb is going into the screen only, na? Say yes or no. So that is what? Into the screen. So magnetic moment. One arrow, imagine it is going into the screen. What tail of the arrow looks like? Cross only, na? So this is a aerial vector also cross and length vector also inside only, na? Yes or no? I will represent hereafter magnet as a like this. Any problem to you? I will represent bar magnet as a arrow mark. That is representing magnetic moment direction. Magnetic moment means south pole to north pole. Means this is a bar magnet. This side is south pole, this side is which pole? North pole. If the arrow is like this, what is the meaning of that? South pole and north pole. Hereafter, in all publications, you observe bar magnet means they will represent like that only. You people should understand, oh, tail is south pole, head is north pole. They will represent like this. Means two magnets are there. Clear? Huh? Two magnets, one is like this, one is like this. When what do you say? Next?
He's asking, this is new chapter or continuation of magnetism, sir.
Moving charges and magnetism is over. Anyway, last Monday I did not take. I will cover that now also. Okay, more 2 periods we have, I think. 1 second.
2 periods. Today one, tomorrow after lunch 1 period.
Only 2 periods, huh? So mostly I will finish that. You missed only last Monday torque and
Torque we finished.
torque
Catching on a current carrying loop in a uniform.
Finished. Very good. Finished. Magnetic moment not finished. M/2L, that 2 pending, na?
Yes.
I will explain this. That last Sunday topic I will explain now. Okay. I hope you understood now. So one formula I will introduce. Please remember, magnetic moment equal to how much? Pole strength into length vector equal to current into aerial vector. Okay. Some IIT problems based on this concept. Now we'll enter. Okay. One small question. Listen the question carefully. 1 minute time I will give you, just try. This is one bar magnet ray. This is south pole. This is north pole. its magnetic moment is how much? Capital M. Understood? Or else one more important thing, easily I will explain. One magnetic wire I am taking. What is this? Magnetic wire. This is which pole? South pole, north pole. This is the direction of the magnetic moment. Na? How much that is? Capital M. Capital M. Now what I will do? I will bend in the shape of an arc like this. I will bend in the shape of a arc. Yes or no? Here angle formed is theta. Find new magnetic moment. Find a new magnetic moment in terms of capital M and theta. Try for 1 minute. It is your IIT question only. Try for 1 minute. Think. For you, once again, I will repeat. Listen question carefully. This is a magnetic wire ray. Its magnetic moment value how much? Capital M ampere into meter square. Now I bend in the shape of a arc shaped wire. Find the new magnetic moment. Find a new magnetic moment. Okay. Come on, action. You should assume 12. These are IIT question only. Every year one question will come. Okay, student, it is my turn now. Listen. Over time. Over. In the first case, capital M equal to how much? Shall I write pole strength into 2L? Now I bend in the shape. I will keep aside equation number 1. Now I bend in the shape of arc. Na? So this is a, let's say, positive charge, negative charge. The shortest distance only. Na? I will assume this is R and this is theta. This is how much? Theta by 2. This is also how much? Theta by 2. So what is the distance? What is the length of this? Tell me. Capital R means this is R cosine theta by 2. This is R sin theta by 2 only. Na? Say yes or no? This also how much? R sin theta by 2 only. Correct or wrong? Now tell me what a new magnetic moment equal to? Pole strength into shortest distance between them only. Na? This is or no? So 2 into R into sine of theta by 2. Say yes or no? And what about the L equal to, this length of the arc 2L equal to how much? Length of the 12 equal to how much? R into theta only, na? Length of the arc equal to radius of the arc into angle of the arc. That concept you know, no? No or don't know? Max you don't know, right? If you take a arc length L, is the radius R, angle theta. Length of the arc equal to R into theta, na? Of course, you are a pandemic gang, na? Pandemic victims, okay? Anyway, please record this, very important one. R value how much here? 2L by theta only, na? So substitute here. So what about new magnetic moment? M into 2 into 2L by theta into sine of theta by 2. What a product of pole strength into length? Capital M only, na? Yes or no? So 2 into capital M into sine theta by 2 whole divided by theta. This thing you should remember at your fingertips. Yeah. Any straight magnet, if it is bent in the shape of a arc angle theta, that is a direct memorized formula. You people compulsory should remember. One problem I will give, stop writing there. Find the magnetic moment of the semicircular magnet. It is semicircular shape. Find before bending, when it is straight, magnetic moment is capital M. What a new magnetic moment? Theta value you have to put only pi, na? That's it, no? Say yes or no? So what a new magnetic moment? 2m divided by pi. That's it. Copy. Switch off this. That is on only, no? This you don't know, very chill. No, that you turn on. This 11th Coimbatore CC04. It hereafter permanent. 11th NEET Madras CC01. Same password. 12th NEET Madras CC02. For these people, Madras CC04. For that people, Coimbatore CC04. Permanent. Fixed. Now one more problem. 1 minute time I will give you, just try. This is one bar magnet, south pole and north pole. Its magnetic moment is capital M, and one more bar magnet I place like this, south pole and it is north pole. Its magnetic moment is 2m. They'll repel, but forcibly I kept like this with some Fevikwik. This angle is theta. Find the net magnetic moment. Find the net magnetic moment. Your answer should be in terms of m and theta only. Only 1 minute time. Magnetic moment is 2m. Distance I did not give, not required also. Okay, your answer, Kamlesh, Venkatesh. Wrong. So here concept parallelogram law of vector addition. This is M only, na? This is what 2m. Should use parallelogram law of vector addition. This mu construct here, 2mu construct here. So the diagonal is representing the net magnetic moment, na? What is resultant vector formula? Under root of a square plus b square plus 2ab into cosine theta. So a value how much? M square plus 2m whole square plus 2 into a value m into 2m into how much? Cosine of theta. If you simplify, under root of m square plus 4m square plus 4m square into cosine of theta.
9m.
So how much? 5m square plus 4m square into cosine theta. M square if you take outside, m under root of how much? 5 plus 4 into cosine theta. So this is the resultant magnetic moment. No need of remembering, that is your answer. Parallelogram law vector addition also we have to use. Okay. Now our next concept is magnetic field. Magnetic field due to a pole strength or pole is analogous to electric charge. Listen carefully, everyone. If you take any electric charge Q, There is one point P is there at a distance R. It is positive charge means what direction of the electric field? Away only, na? Correct or not?
Yes, sir.
What electric field value? K into Q by R square. Where K is called 1 by 4 5 epsilon naught into Q by R square. Same analogous concept. Now positive charge is similar to North Pole. Of course, monopole does not exist, but I am taking it as a North Pole. Let's say its pole strength is small m. Here charge is analogous to pole. And there is one point P is there. At a distance how many meter? R meter. This positive charge will repel or attract? Away only, na? So the magnetic field is denoted with the B. Understood? Electric field is represented with the E. Magnetic field is bar magnet, na? B for bar magnet, like that. Magnetic field is away. Same concept. Magnetic field equal to K M by R square. But K is called shabash, mu naught by 4 pi. Where mu naught is called permeability of that free space between the charge and that point. So, what a magnetic field due to North Pole? Mu naught by 4 pi into M by R square. Now, in the place of North Pole, if you keep any South Pole, what a magnetic field will be? Inwards. South Pole means negative charge, na? If you take any negative charge at the point P, how the electric field is? Inwards. So South Pole also will produce the magnetic field inwards. But same magnitude it will have. Mu naught by 4 pi into M divided by how much? R square. Be careful, M is the pole strength, not magnetic moment. What a small m means? Pole strength. Now we'll take a bar magnet. One small problem, right? Will you try a copy? Just stop. Listen carefully. Listen the question carefully. Listen the question carefully. This is one bar magnet. This is one bar magnet. It is, for example, North Pole. It is what? South Pole. What is this? Midpoint. Let's say the distance between the North Pole, I mean length of the dipole is 2L. Its pole strength is plus small m. It is minus small m. There is one point P. The imaginary line which is joining North Pole, South Pole and point P is called which? Axial line or principal axis, etc. This point P, all distance are measured from origin only, na? Let's say that point P is at a distance R meter. Now my question, find magnetic field at point P. Find net magnetic field at point P. My second question, find direction of the net magnetic field. Only each question 1 minute time. 2 minutes you want? Okay. 2 minutes time each question.
Net magnetic field of the point is mu naught by 4 pi n by L2.
Okay, any more answers?
Direction of the inwards.
Inwards. This is alone correct. Direction of the net magnetic field is inwards. Very good. Right answer. First one is right.
Mu naught
by 4 pi m into 4a by r cube.
M into
Mu naught
4a by r cube.
mu naught 2m 2 into m
hmm,
into r
hmm,
by L square
hmm,
plus r square
hmm.
the whole square.
Wrong. Partially correct only, but fully wrong. Okay.
By 4 pi into m into 4a by r cube.
M into 4a na. A y. What is A? Re?
Distance between north and north pole and
R. That is not A.
அங்க படிக்கும்போது இதே படிச்சாரா யார்
எங்க படிச்சும்போது ஸ்கூல்ல ஸ்கூல்ல ஏ சொன்னாரா?
புக் டெரிவேஷன்
ஓகே ஓகே ரெண்டு ஆன்சர் ராங்க ரெண்டு பதில். இப்போ நல்லா கவனிங்கனா நல்லா கவனிக்கங்க. நல்ல கவனிங்க. Last word only problem. That sentence I know. Governing-na, governing-na. Okay. At point P, how many poles are producing the magnetic field? Negative pole will produce inwards only, na? Inward and very strong. Maybe very near, na? But north pole will produce away and very feeble. So what net magnetic field? Left side only, na? Correct or not? So you can write net magnetic field equal to how much? Bs minus Bn. What a magnetic field due to south pole respond? The distance between the south pole and point P, how much? From R you have to subtract L, na? From R you have to subtract L. So R minus L. Magnetic field due to south pole, how much? K into M divided by R minus L whole square. The magnetic field due to north pole?
K into M
divided by
plus
Shabash. From here to here, how much? R plus L. So R plus L whole power 2. If you take the LCM, this one into this one, na? What do you get? R minus L into R plus L, R square minus L square whole power 2. And Km I will take outside. Full bracket will start. This term will come here now. R plus whole power 2 minus this one will come.
R minus.
R minus L whole power 2. So if you simplify it, K into M into, if you simplify, what do you get? R square plus L square plus 2RL minus bracket will start.
R square plus L square
minus 2RL and whole divided by
R square plus
R square minus L square whole power 2. Here minus R square plus R square katam plus L square minus L square also will be katam. So net magnetic field how much? K into M into 2RL plus 2RL 4RL. So one thing I will do, M into 2L and 2R I will write. Do you have any problem if I write like this? But a product of pole strength into length, magnetic moment only. So K into M
2R.
2R divided by R square minus L square whole square. L not negligible. It is a long dipole. Short dipole, as Vishwanath told, it is neglected. Long dipole means all points are near points only. Na?
Then K into 2M by R.
So what is the magnetic field at any axial point? 2K M into small r divided by R square minus L square and whole power 2. K value mu naught by 4 phi na. So you should remember at your fingertips. For electric dipole also same answer you will get. Have you noticed electric dipole in electrostatics? That is how much? 2Kp small r divided by R square minus L square whole power 2. Say sir no. But what about the short dipole? This is valid for only for long dipole, na?
2Km by R.
For short dipole means very important note. For short dipole means length is very small, na? Means L square is very smaller than R square. If you neglect totally, should put L square value 0. So you will get
R power
2K M by R power
cube.
3. This also you should remember. Just like 2Kp by R cube in the electric dipole. Equatorial. This is axial line. Axial line. In the next one, equatorial line. Next one, arbitrary line. First you copy quickly. After copying, find in the equatorial point or perpendicular bisector. Okay. Find the equatorial point or perpendicular bisector. These results you should remember at your fingertips. Okay. Time saving tricks. Okay. Now perpendicular bisector. Same thing I have to do. I'm taking one long dipole. What is this? Look here. Time over. Look here, everyone. This is a north pole and south pole. Its pole strength is plus m. Its pole strength is minus m. This is the origin. This distance is L. This distance is L. What the name of this line? Equatorial line. Why I am equatorial line? It is bisecting the magnet into two equal halves, or perpendicular bisector also you can call. There is one point P on the equatorial line at a distance r meter. Understood? At this point P, how many poles will produce magnetic field? Two. One is north pole will produce magnetic field away or towards? Very good. Away. And other one, south pole will produce a magnetic field towards. And in fact, magnitude of Bn must and should be same as Bs only, no? Why? Same pole strength and same distances also. So I will remove this B and B only. This angle theta means this angle also theta, this angle also theta, this angle also theta. B has how many components? B cosine theta plus B sin theta. This B has how many components? Plus B cosine theta and how much? Minus B sin theta. Plus B sin theta minus B sin theta cancels, no? So what is the net magnetic field? B cosine theta plus B cosine theta how much? 2B cosine of theta. So net magnetic field equal to how much? 2 into B is nothing but magnetic field due to each pole, no? How much? K into small m divided by distance between them, how much? Under root of r square plus L square. So under root of r square plus L square whole power 2. What about the cosine theta? Adjacent side by hypotenuse, no? L by hypotenuse. Under root of r square plus L square. But a product of m into k, m into 2 into L, m. So very good. K into capital M, square and root cancels out. R square plus L square into this one.
3/2.
Very good. R square plus L square power 3/2. So this is a also memorized formula. Compulsory, you should remember. But it is valid for only long dipole.
Short dipole R.
Short dipole, what I should do?
Km.
For short dipole,
L is equal to 0.
L square is very less than R square. So L square I can put 0. If you substitute here, what we can write? K into M by R cube. One very important relation, students. Listen carefully. This is many times asked. Listen carefully. South pole, North pole. If you take any particular point P, what net magnetic field at any axial point? Away like this only, no? Away. Away. North pole is very close means this magnetic field is very predominant. So B is away. Now if you take any equatorial point, here magnetic field is away from North pole, no? Have you noticed axial magnetic field and equatorial magnetic field both are opposite direction only, no? And what is the axial magnetic field value?
2 into
2 km by r cube. This is
Km by R cube.
minus km by r cube. If you divide them, what we can write? Axial magnetic field is equal to how many times? Minus 2 times of the B equatorial, no? One is positive x-axis, other one is minus x-axis. Compulsory opposite direction. This is a one more relation to be keep in your mind. Magnitude, what will happen? Axial magnetic field magnitude, what will happen? 2 into equatorial magnetic field. Yes or no? These two relation compulsory, you have to keep it in your mind. Is there any rule? Only you need to find magnetic field at axial point, only at equatorial point. Is there any rule? Arbitrary point also you should find, no? Yes or no? So that's what we will do. This is one copied. Last will copy. Then directly I will teach. See, one bar magnet is there. Now hereafter, I will represent the magnetic dipole like this. Any problem? No problem. It is a short dipole only. What the name of the line? Equatorial line. What is the name of this line? Axial line. Now there is one arbitrary point P is there at a distance from origin R meter, subtending some angle theta, magnetic moment of the dipole capital M. Find magnetic field at point P. Now this magnetic moment I can divide into two components. One is M cosine theta and other one is what here? How much? M sin theta. This step understood? Huh? For this M cosine theta component, point P is axial point only. Na? One dipole, I mean one magnet, I am dividing into two magnet. One is M cosine theta, M sin theta. Now focus only M cosine theta dipole. That point P on the axial point only. Na?
Yes, sir.
M cosine theta is dipole mean point P on the axial line only. So that will produce magnetic field away only. Na?
Yes, sir.
Axial. Now you forget M cosine theta. Now you remember M sin theta magnet. For M sin theta, point P equatorial line only, na?
Yes, sir.
Say yes or no. So that magnetic field is away from the north pole, no? This is north pole means away from the north pole only, na? Say yes or no. So that is the equatorial magnetic field. I want net magnetic field. So construct one parallelogram. This is only what here? Net magnetic field.
Yes.
Understood? What about the net magnetic field equal to under root of how much? Axial magnetic field whole square plus equatorial magnetic field whole square. What is the axial magnetic field whole square formula? 2 km by r cube. But m value m cosine theta. Na? So 2 km cosine theta by r cube whole power 2. What is equatorial magnetic field? Km by r cube, but m value m sin theta by r cube whole power 2. Km by r cube whole square I can take outside. Na? So Km by r cube I can take outside. And under root of 2 cosine theta whole square means what? 4 cosine square theta plus sin square theta. So Km by r cube and under root of how much?
4. Sir.
Huh? Hmm?
4.
What I can write? 3 cosine square theta plus cosine square theta plus sin square theta I can write. Na? Cosine square theta plus sin square theta 1. So this net magnetic field at any arbitrary point how much? Km by r cube into under root of 3 cosine square theta plus 1. Should remember at your fingertips. Is my point clear?
Yes, sir.
Very important one. Direction also important. Direction is some alpha. Direction means angle between net magnetic field and axial magnetic field. How to find? Tan alpha equal to how much? This is opposite side by adjacent side. Na? Opposite side is equatorial magnetic field by axial magnetic field. No? Yes or no? So tan alpha is equal to what is equatorial magnetic field? Km by Km sin theta by r cube. What is axial magnetic field? 2 km cosine theta by r cube. R cube, km cancels. Sin theta by cosine theta, tan theta. So tan alpha equal to how much? Tan theta by 2. Alpha equal to how much? Tan inverse of tan theta by 2. This also you should remember at your fingertips. Before going to IIT exam hall, compulsory this all formula should keep it in your mind. Then only your brain will respond very quickly when you are doing any numerical. In fact, before doing numerical also, you should revise concept like this. Then only any problem guided by brain very quickly. Clear? Understood? Copy quickly, I will explain. Where you want to copy? This only equatorial line. Should I send the screenshot? Will you copy
Yes, sir.
in WhatsApp group? You want question? You don't want concept, and torque I will explain. Concept I will explain. You people should do more problems. You cannot do. The doubts you have to ask us should come. Then only your speed will increase. Confidence will increase. Committing mistakes will decrease. You will know the JEE mains pattern. Understood? All material problems are your problems. Understood? In school also, fresh mind is there. Physics, chemistry, maths, you don't need to listen. Here we are explaining everything. Sit in the back bench and work out problems. Not for me, I am telling. I am not any selfish. For you only, you have to go to IIT and NIT. I am not separating you and school. I am telling one plan. Right or not? Okay, work out like that. Weekly 1 or 2 days, bunk the school and work out problem. Come here for doubt clarification like that. Correct or not? These 5 months, I have to accept a very difficult period for you. But at least for getting 200 out of 300, these things you have to do. Clear? Again, 11th status, I don't know. If you come also, 11th standard, you can sit. LT, this class, that class. Some concepts also you can listen. Are you understanding? Plan accordingly. One concept I will explain. For example, this is one north pole of the bar magnet. Listen to it. Don't copy. I will give. Listen carefully. Pay your full attention. This is the south pole of the magnet. What direction of the magnetic field? Always from north pole to south pole. This is a uniform magnetic field. Right side. This is north pole, this is south pole. Magnetic field line act from north pole to south pole. You take a capacitor plate, this is positive charge like north pole. South pole is just like a negative charge. But direction of the electric field from positive charge to negative charge only. Correct or not? Now, in between this is actually top view. I suspended one bar magnet like this. with a string suspended on bar magnet like this. Here one bar magnet like this. Here North Pole, here South Pole. The top view and I have drawn. Which view? Top view. Let's say this is South Pole and North Pole. What will happen? South Pole attracted by North Pole, North Pole attracted by the South Pole. Both are equal and opposite forces only, no? Why? Magnetic field is nothing but force acting on the one pole. Like electric field equal to force acting on the one charge. Force is analogous to force. Pole strength is analogous to charge. You know, these two anti-parallel forces will contribute torque, clockwise torque only, na?
Yes, sir.
Correct or not? So what a torque on the magnetic dipole? Perpendicular distance into force only, na? If you assume this angle, capital magnetic moment, this angle is theta. What a perpendicular distance? 2L sin theta only, na? Will magnify.
Yes, sir.
This is 2L means, this is theta means, this angle 2L sin theta only, na? Say yes or no? So perpendicular distance how much? 2L into sin theta, and magnetic force how much? Small m into capital B. What a product of pole strength into length? Capital M into B into sine of theta. So what a total torque acting on that magnet? M into B into sine of theta. Everyone should remember at your fingertips. But you know, torque also vector quantity, no? Only two directions is there. One is clockwise direction, another one anti-clockwise. Clockwise means minus z axis, anti-clockwise means plus z axis. So this is vector means M also vector, B also vector. So cross product you have to use. So torque vector equal to how much? Very good. M vector cross B vector. This is the total torque. A capital M only. Be careful, capital M only. The total torque acting on this. Magnetic moment I did not explain. Huh? Okay, tomorrow I'll explain. Of the current carrying loop, not explain. No? I'll explain. Tomorrow earth magnetism I have to cover to you, and that miscellaneous also I'll explain. Okay, now you can leave. I will take. Only this one, no? This only, no?
We bag